Easy go.
Hi everyone, welcome to Mr. H Math Lab. We are on the third video for Unit 7, Practice Test for Math 1 student. Number 17, find the area of a triangle RAT, given that AR perpendicular to RT. So we know AR and RT are perpendicular, which means they cross at 90 degrees. Show your work, hence find the measure of the base and the height using the distance formula. So I give you the distance formula, area equal to 1/2 base times height. So first we're going to find the distance of the base. Let's say if I call this is my base, is the RA. Then I need to find the distance of RA. R, the coordinate is 1, 3, and A, the coordinate is 5 and 1. Distance formula. D equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So what we're going to do is plug them in. x1, y1, x2, y2. That will be 1 minus x2 minus x1. That's going to be 5 minus 1 squared plus 1 minus 3 squared. 5 minus 1 is 4 squared, plus 1 minus 3 is negative 2 squared. So that will give me 16 plus 4, which is square root of 20. So the base is square root of 20. Now we're going to look at the height. The height is RT. So same concept. R, the coordinate is 1, 3, and T, the coordinate is negative 2, negative 3. Okay, distance formula. D equal to square root of x2 minus x1 squared plus y2 minus y1 squared. x1, y1, x2, y2. So that would be x2 is negative 2 minus x1 is 1 square plus negative 3 minus 3 square. Negative 2 minus 1 is negative 3 square. And be careful, negative 3 minus 3 is negative 6. Some of you are going to give me 0 here. Make sure they're the same size, you add them. So that will give you 9 plus 36. That would be square root of 45. Yes. Okay, so area of triangle is 1/2. Base times height, which means 1/2. Square root of 20 times square root of 45. So 1/2 times square root of 20 times square root of 45. That will give me the answer is 15. So that's it. The area is 15 for number 17. Okay, if you need more time to copy it down, go ahead, pause the video. Now we're going down to number 18. Alright, so if JK is 2x minus 2 and KL is x plus 5. Find the value of x and the length of JK and KL. Alright, so this is the segment. K is in the middle, in the between of J and L. So we use the betweenness of points. JL equal to JK plus KL. JL is given is 11.4. JK is x minus 2. KL is x plus 5. So we will go ahead and solve for x. X plus x is 2x. Negative 2 plus 5, so you subtract them, give you positive 3. And bring down 11.4. To get x by itself, you're going to do is minus 3 on both sides. So 11 minus 3 is going to be 8.4 equal to 2x. and we divide by 2 on both sides. X equal to 4.2. Okay, give me a second, let me check the work really quick to make sure I didn't make any mistake. 2x, 3, yes, minus 3 on both sides. So that will be 11 minus 3 is 8.4, and divided by 2 is 4.2. Yes. Alright, so when x is 4.2, we can go back and find the j, k, and kl. We're going to start with jk. jk is x minus 2, so that will be 4.2 minus 2. That will be 2.2. Okay. And kl is x plus 5. That will be 4.2 plus 5. That will give you 9.2. Then we can check the answer really quick. 9.2 plus 2.2. That will give me 11.4, and that's matching with our total length. So we good. Alright, number 19. Okay, number 19. Cynthia found the perimeter of ABC shown below. Given A is 3, 2, B is 3, negative 3, and C is negative 4, 1. And she used the distance formula to find the length of AB. And she said this is 5. The length of BC, this is 8.1, or square root of 65. And AC is square root of 40, or 6.3. So, perimeter, she added them all up. She knew by looking at the diagram her work that her solution was incorrect. Okay, we know it's incorrect. How could she tell and find and correct her mistake? And what is the correct measurements of the perimeter? Alright, so we're going to check her work to see what was wrong. I'm going to look at AB first. AB, her answer is 5. We can check the distance formula, but since AB is the vertical lines or horizontal line, and you can count the boxes. It's 1, 2, 3, 4, 5. So the distance is 5. That's correct. Now we go to BC. However, BC is diagonal line. It's not one full box, so you cannot count it like you did earlier. So this doesn't work for BC. Alright, so BC look like she labeled this is B is x2, y2, and C is x1, y1. So we have y2 minus y1. Okay, so she used as the formula, x2 minus x1 squared plus y2 minus y1 squared. x2 is 3, so you plug in 3, that's correct. Minus x1 is negative 4, so it's negative 4, that's correct. Negative times negative is positive, so this is 3 plus 4 give you 7 squared is 49, that's correct. Now we're going to look at y2. y2 is negative 3, yes. Minus y1, which is 1, yes. And negative 3 minus 1, you're going to add them as negative 4. Square is 16. And 49 plus 16. Oops, 16. That is 65, yes. And square root of 65 equal to 8.1. That's correct. So BC is correct. Now we go to AC. So 3, she named A as second point. I don't know why it's moving that way. X2, Y2, XBC, X1, Y1. So X2 minus X1, X2 is 3 minus X1. We see the problem now. the x1 is -4 and she put in -1. So that's the reason why AC is the wrong answer. So we're gonna do is find AC on the side and then come back to find the perimeter. I'm gonna bring down my A. A coordinate is 3, 2, and C is -4, 1. AC equal to square root of x2 minus x1 square plus y2 minus y1 square. x2 minus x1, so we're going to label it x1, y1, x2, y2. x2 is -4 minus x1 is 3 square plus y2 is 1 minus y1 is 2 square. So that will give us -7 square plus -1 square. That would be square root of 49 plus 1 is square root of 50. And square root of 50 is 7.07. So I will call it 7.1. We round it up. So perimeter is the sum of all three sides. So that would be 5 plus 81. Sorry, 8.1 plus 7.1. That will be 5 plus 8.1 plus 7.1. That will be 20.2. And that would be it. Yes, that's it for number 19, and that's the last problem. I hope that you study well. Make a flashcard. And if you have any question, you can ask me in class, before school, or after school, before Friday. Alright, good luck everyone. Thank you for watching. Don't forget to like and subscribe. Thank you.